Welcome back, young scientists. In this video, we're going to try and squeeze 4 gas laws all in together, but they're all pretty interrelated and all pretty simple, so we should be able to get it done. Now, just review from math class real quick. Remember that a direct relationship is when one thing goes up, the other thing also goes up. And an indirect or inverse relationship is when one thing goes up, the other thing goes down. That's going to be important for our laws in this one. Remember, we talked last time about kinetic molecular theory, otherwise called collision theory, and how we're going to use it to explain the movement of particles. That they're going to behave what we say is ideally, not really, and that being at higher temperatures and lower pressures makes them more ideal. Also, a quick review. Remember, pressure is the number of collisions and the force of the collisions between gas particles and their container. So we're going to keep that in mind as we talk about pressure in the coming slides. All right, our first law is Boyles Law, and it says that pressure and volume are inversely proportional, or the pressure of a gas times its volume equals the new pressure of the gas times its new volume. If you squeeze a balloon, the volume goes down and the pressure goes up. If you let the balloon expand, the volume goes up and the pressure goes down. P1V1 equals P2V2. So as an example here, the gas in balloon has a volume of 4 liters at 100 kPa. The balloon is released into the atmosphere and it expands to 8 liters. What is the new pressure? So we're going to say pressure 1 times volume 1, 100 times 4, equals pressure 2 times volume 2. So 100 times 4 equals P2 times 8. Hopefully you see if the volume doubles, the pressure halved. So the new pressure is 50 kPa. Another practice here, go ahead and read through it. I think you guys can probably handle this on your own. And one more, you guys know the drill. Pause the video, go ahead and give it a shot. When you're ready, we'll move on to the next thing. Okay, our next one is Charles' Law, which says that volume and temperature are directly proportional. If you heat up a gas, it expands. If you cool off a gas, it contracts. So we get that directly proportional graph. V1 over T1 equals V2 over T2. So if gas in a balloon occupies 2.5 liters at 300 Kelvin, what temperature will cause the balloon to expand to 7.5 liters? So we'll say 2.5 over 300 equals 7.5 over T2. You do a little cross multiply and divide, but really, if the volume tripled, that means the temperature tripled, so it'll be 900 kelvins. Again, read the problem, pause, give it a shot, then move on to the next thing. Gay-Lussac's law is basically the same as Charles' law, but now with pressure. Pressure and temperature are also directly proportional. As temperature goes up, pressure goes up. Or as pressure goes up, temperature goes up. If you squeeze a gas, it'll start to get hot. If you heat up a gas, its pressure will start to climb. Solving this is exactly the same as solving Charles' law. You'll say pressure over temperature equals new pressure over new temperature. Cross multiply and divide, find the new pressure or find the new temperature. Here are a couple problems for you to practice with again. Now, what you may, however, notice is that the 3 gas laws we've talked about in this video all talk about the same 3 properties. And what scientists from a number of places all figured out at mostly the same time was you could slap them all together. This is what we call the combined gas law. See, we've got P1V1 equals P2V2, just straight across the top. We have V1 over T1 equals V2 over T2. And we have P1 over T1 equals P2 over T2. But you can just do all of them at the same time. And this is the combined gas law. As with all of our calculations here, temperature must be in Kelvin. Otherwise, you're going to end up with negative pressures and volumes, and everything's going to be terrible. So if we look here, a gas at 110 kPa, that's our pressure, and 30 Celsius fills a flexible container with an initial volume of 2 liters. If the temperature is raised to 80 Celsius and the pressure increased to 440 kPa, what is the new volume? So the first thing you're going to do here is get those temperatures into Kelvin. Add 273 to each of them. Then you'll set up your P1V1 over T1 equals P2V2 over T2. And you'll end up just solving for V2 like you would in math class solve for X. This feels like it's a little more complicated just because there are more values, but really it's just plugging in numbers and solving. Go ahead and pause the video, give it a shot. And one more time, 0 Celsius, 1 atmosphere, 30 milliliters, 30 Celsius, 20 milliliters, and they want the new pressure. Now, as I said in a previous video, if you want to put milliliters on both sides of your equation, that's totally fine. You can do the whole thing in milliliters. Just make sure that if one side says milliliters, the other side also says milliliters. The thing that's not fine on this problem is that Celsius. Again, make sure that's into kelvins first. And then the solving, it'll still be the same thing. Just get the new pressure by itself. So that was the combined gas law. It's a combination of Boyles, Charles, and gay-Lussac's laws. Hopefully this is all fairly simple algebra for you. It's just a matter of identifying the variables and plugging them into the right spot. And from there, solving shouldn't be too bad. This is another shorter video. We're going to talk. Hopefully I can get everything together in one final video, and that'll wrap up gas laws for us.